Hi, welcome to Analytics for All. This is the first lesson in a series I'm going to do on database development design. This first lesson is entitled, What is a Database? Now this title should let you know this is very much a beginner's course. This is an introduction to databases, what we do with them, why we do it, what we build with them, how to build one. We're going to focus mostly on relational databases, your standard SQL databases. We'll touch on the NoSQL world, the unstructured world out there, but we're really going to focus on relational because it's a beginner's course. If it helps you to have something to read along with, I do have a write-up on my website, analyticsforall.org, which I will place down in the description, and it kind of goes through everything I'm going to talk about here. And like I say, this will be down in the description for us to work on. But let's just start with what is a database and why do we need them? Well, think about there's a lot of hot jobs when you look on the tech field out there: data scientists, data architects, data analysts, data engineers, database management. These people all work with databases for a living, and they're all very good jobs that pay well. And a lot of people and there's a lot of need for people to work with them. So a database, what it is a software platform designed to store, manage, and manipulate data. They come in different flavors, from your small desktop databases all the way up to these large enterprise solutions that sprawl across entire data centers, multiple servers, or up nowadays mostly up in a cloud somewhere. They're used for all types of businesses, and all types of personal uses and transactions. A simple one, I like to try to say to kind of break them apart, is examples of, I call a transactional database versus a data warehouse. Now, these are both under the phrase of relational databases. These are still the SQL, not the NoSQL, which we'll get into. So a transactional database, a good example is to think of a cash register. You go up to checkout at the grocery store, and every time you scan your item, the computer searches the item, says, oh, this item's cost $1.50, adds it up to the tally, subtracts it from the inventory of the store, and you pay, and the whole thing's in there. And it's all done each person, hundreds of thousands, can go through a store in a day of transactions. Quickly rewritten, updated, that whole thing. Data warehouses, on the other hand, they're designed more for reporting, aggregation, so they don't update it often, maybe once a day, maybe every 12 hours or so. Think about the data warehouse as at the end of the day when the store manager wants to get the totals of how much was sold and how much of this was sold. They don't really care about how much did Ben Larson buy at the. Doesn't care about every thing I bought. They just want to know totals. They want aggregates, and that's data warehousing. Now let's get some terms quickly out of the way that you're going to see pop up. One you're going to see is called OLTP. This is the transactional database I told you about. This stands for Online Transactional Processing. Sorry, I'm running off the page here. 1 second, let me fix that. Okay. All right, Online Transactional Processing, or OLTP. That is what I said. That's our transactional databases. That's the cash register I'm telling you about. The other one, you'll see the phrase called OLAP. Now, OLAP stands for Online Analytical Processing. And for the words analytical, it makes you think that's reporting. So that's, like I said, that's the data warehouse. That's the reporting structure. So if you hear these phrases, somebody mentions OLTP versus OLAP, that's what they mean. So this OLTP is your more transactional database. Your OLAP is this is your online analytical. This is your data warehousing. These are both still under the phrase of relational, though. We still are in the world of relational databases at this point. Now, the next phrase I want to kind of just get out of the way here is SQL versus NoSQL. And it's always spelled like that, the lowercase o. And so SQL stands for SQL, if I can spell this correctly, Query Language. And what it is, it's a series of programming tool. It's a programming language, basically. It's designed to work with data. It helps you query or search data, helps you manipulate data, helps you put data, build stuff in a database. But that's SQL, and that's SQL Query Language, and that's what's used in the relational database world that we're going to be working in mostly here. Now, NoSQL, we get back over here so I can get my cursor back. Oops. This stands for Not Only SQL. And what this means is this uses this can infuse a lot more areas out there. This goes into document folders, unstructured data. Now, unstructured data can be anything from documents to pictures to audio files to just long, text readouts that aren't structured. If you just got a transcript somebody wrote, letters, that kind of stuff. That's all unstructured. So NoSQL, not only SQL, it means you can still use SQL in some of it. You actually do. You parse through that, like with Splunk logs. And if you ever heard of Splunk, it's a logging thing. You parse through these big text files and you say, I'm looking for these words and I want them to pop out. So you can use SQL to do that, but you can use a lot of other tools to work with these types of files, and that's why it's called not only SQL. SQL itself will not handle a lot of this, so you have to use other modalities and that kind of stuff to create these different databases that are called the NoSQL databases or the unstructured databases. Now, SQL is still king of the world right now. The majority of the data you're going to work with out there, unless you get into very specific research type thing, you're going to be working with a relational database. That's what the world exists on. That's what we all know. We all understand it. And it's very functional, very upfront, and it is definitely the majority of databases out there at the moment. These databases, again, all fall under the umbrella of all. Let me go back to the screen here so we can write this out. It's called RDBMS. Okay? RDBMS, and that stands for Relational Database Management System. And what that is, that's the software behind managing the database. You might have heard terms such as MySQL or SQL Server or Oracle. All right, so these are all management systems. These are all the software that manages the data here. And that's why it's the management system. RDBMS, they store data in tables. Okay, and the tables have columns and rows. Think about when you're looking at an Excel sheet or a Google sheet. They're typically handled to set up specific data, like you'll have an HR database, which will list HR information. You'll have a student grade table. And the tables can be joined in SQL to create rich data sets. So let's take a look here. So we've got an example here. So I've got these two tables here. And I have a list of teachers to the left on the classes they're going to teach. And then we have the classes here sitting on the right. Okay. Now you can see if you look at the column to the left on the instructors, each instructor has an ID, 1, 2, 3, 4. And then you can go over the class list to the right, and you have the final column, you have instructor ID. So you can sit there and look at the first class, Brewing Beer. Instructor ID is 2. You go across and you see that's Dr. Carlson. Caring for Tigers, number 4, it's Dr. Doolittle. And so you can see that's how you can join these tables in a relational database. So that allows you to create a richer set. You can just combine the tables without having, you don't need to cut and paste. You can just join the tables through a simple query. Now, another phrase you're going to hear commonly when talking about databases, especially relational databases, is called normalization. Normalization is a method of breaking the data apart and, really kind of just taking a look at how we can, separate it, stop things like duplications, that kind of stuff. If we actually go ahead and take a quick, we're going to really get into normalization in some later lectures, so I don't want to spend too much time on it now, but just taking a quick look at here. This is an example of normalization. So what I had is I could have just, in the instructor section, just wrote their name. But now we'd have a database where this teacher's name was listed multiple times, in multiple tables, which for storage purposes is not good, for lookup purposes is not good, for referential integrity, for all these things. It's just much easier just to use these numbers and say, hey, so that way we can join the tables. So instead of writing Dr. Carlson here again, I just send over his ID, and I use his ID. And it breaks up the tables into nice small tables that you can manage. And it's just something we're going to get, like I say, deeper into. But just know that normalization is really a phrase you're going to hear a lot within database management. Now, another thing you're going to see in relational database design is we have what's called a set of rules called the ACID test. And that's a list of rules you really need to follow to get a good, strong database. And the ACID stands for, number 1, atomicity, the integrity of the entire database transaction. If you just want to be updating a person's first name, the entire value must get updated to be successful, not just the first letter. So there's no partial transactions being processed. The consistency, only data that pass validation rules are permitted. Example, email addresses that require that @ sign. Otherwise, it's not an email address. It shouldn't go to the database. Isolation, and that's the ability for a database to process multiple transactions simultaneously. If you're performing 2 updates, the first update must complete before the second. And durability. Once data is saved, it should remain saved even when the machine shuts down. So if the machine blows up and shuts down in the middle of an update, it should roll back to what before happened. So it shouldn't just have the partial update. But if the update is complete before the machine shuts down, then when you restart, the update should be in there. Now, relational databases, say they're the king. They're what we use mostly. That's up there in the left, right there, relational SQL. But non-SQL's out there for a reason. It fills in the gaps you can't get with the relational databases. And I said non-SQL, you can look at, you have things like document, you have key value pairs, which are kind of like dictionaries if you ever worked that. You have graph databases. Now, you want a good example of graph databases, look at like Facebook and Twitter, these social media things where it's the I'm connected to my wife and my wife's connected to her friends at work, so through them there's a connection and you can see these kind of connection feeds, and that's where advertisers, they use this to kind of specialize ads. They say, well, if he's connected to all these other people who all like this, we're going to display this ad for him. And then there's wide column. Wide column is just these massive databases of just thousands and thousands of columns you may not all need. It's almost like a data dump. It's one of those things that, every time I've worked with one, the first thing we do is we clean it up and try to put it in some kind of relational status so we can work with it. But that's what wide column means. And finally, real quick, I just want to talk about scaling. The idea of scaling is to how quickly we can make something bigger. So if I've got a database that was designed to store, let's say, 1 million records, and all of a sudden I go from Amazon and Jeff Bezos' garage to Amazon, the company now. Now we have to store billions and billions. So how quickly can you make it bigger? I mean, and that's one of the problems with relational databases. They can only scale up to as big as the machine or the groups of machines you have on there. You have to actually increase the machine, increase the storage, and it doesn't like spread easily across multiple systems. Even though you might be using more than one computer on a large relational database, they all have to be configured kind of at the same time. They have to be like pre-partitioned. As opposed to non-relationals, they scale out. The great thing about a non-relational database, like Hadoop is a great one I use a lot, is that like there's times when I want to do like a quarterly type analysis, and I bring in all this data, I dump it into there, it scales out really big, I run my analysis, then I just shut it down and just bloop, so it doesn't. So it's very easily, it can go across almost like a parasite and look for empty space or empty availability on other servers around it, and just kind of use it as much as it needs and then close it back down. So it's more elastic with its scalability, which is more cost efficient because I don't have to have machines that sit there waiting for me to do this quarterly thing, and that's the only time I use them. So that's the advantage to this, one of the advantages of the NoSQL world out there. All right. Again, if you like this video, thank you for watching it. If you like it, hit the like and subscribe button. Leave me a comment down below. I build other courses, other classes people want, anything within the world of data science. I say this is a beginner course for people. I also have some more advanced stuff on my website. Go ahead and check it out. I have the link down in the description. Again, thank you very much. This is Ben Larson with Analytics for All.